With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, the wire as shown in the figure is bent in the shape of tent with an angle of theta is equals to 60 degree and L is equals to 1.5 meter and is placed in uniform magnetic field of magnitude 0.3 Tesla perpendicular to that of the table rigid, okay, but hinged at point A and B. If the tent is flattened out on the table in 0.1 second, then we have to find here the average induced EMF and also we have to find the direction of it. Okay, so let's look at the solution. So actually in this question it is given that a wire is bent in the shape of tent at an angle of theta is equals to 60 degree with the length of the side is 1.5 meter, which we can see here, and kept into the magnetic field that is B. Okay, now if this same wire is flattened out onto the table in 0.1 second, then what would be the induced EMF in that wire is we have to find here according to question. Okay, and we have also to find here the direction of this induced EMF. Okay, so first of all we will try to find the induced EMF. Okay, then we will find the direction for it. So here I can say that the induced EMF E can be given by the formula that is minus d phi by dt, and also we know that the average induced EMF can be given by minus del phi, that is change in flux, upon delta t due to change in time, right? So first of all here we need to find the change in flux, that is del phi, and this change in flux is given by the formula that is final flux minus initial flux. Okay, so to find change in flux we need to find the final flux and initial flux, right? According to given situation, a wire is shaped in the form of tent and it is kept onto the uniform magnetic field at an angle of theta. Okay, according to this first situation, so here I can say that the initial flux will become equals to flux due to this square side plus flux due to this two triangular sides, right? So as we know that the flux is given by the formula that is B into A, where B is the magnetic field and A is the required area. So as we can see here, this much of side, okay, of wire is square side, so flux due to this square side can be given by, that is B into A, means I'm considering here the area of this square is A. While let us assume the area for this triangular side, okay, is A dash, so flux due to this triangulars can be given by B into A dash plus B into A dash. Now according to question, this square side is perpendicular to magnetic field, but these triangles are parallel to magnetic field, and as we know the sign 0 value is 0, that means this both of them will become equals to 0, and hence the initial flux will become is equals to B into A. Okay, now let's say the final flux, that is phi A, and this can be given by, now according to question, this is flattened out onto the table in 0.1 second, right? So obviously these two triangles are also become perpendicular to the magnetic field, so this won't be become 0. So here the final flux can be given by flux due to square sides plus flux due to triangles, that is BA dash plus BA dash. Now if you substitute this into the here, so change in flux del phi will become is equals to BA get cancelled, while this will become 2 times of BA dash. Okay, now according to question, we have already seen this triangle is equilateral triangle, and area of equilateral triangle is given by a dash is equals to under root 3 by 4 into L square. Now according to question, side of the triangle is L, means 1.5 meter. So if we substitute here, so this would become under root 3 by 4 1.5, that bracket square. Okay, so here the required induced EMF, or we can say the average induced EMF, would become equals to minus del phi, that is 2 times of B into A dash. Now according to question, magnetic field means value B is 0.3 Tesla into A dash we have found, that is under root 3 divided by 4 into 1.5, that bracket square, divided by time is 0.1 second, right? So after calculating this or simplifying it, we get minus sign of 5.84 volt. Now if we see here, so we have got this induced EMF as minus 5.84 volt. Now let's take the given option. So option first won't be matched because it is 6.75 volt, right? And option D is also doesn't match, that is 2.75 volt. So this both option will become wrong. Now to find the correct option out of this 2 and 3, so actually if we see here, so there is a negative sign in induced EMF. Answer is indicating the average induced EMF is in anti-clockwise direction, right? So according to this, option third, that is average induced EMF in wire during this time is anti-clockwise, would become correct answer for this question. So this is the required solution. I hope you like the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.